Hi, welcome to Nomis Academy. In this video, I will be mocking WAEC past question for you, and we are going to focus on 2024. Let us mock WAEC past questions. Let us see how simple WAEC past questions could be, or WAEC questions could be. Let's take question number 1. This is a theory question for the WAEC past question 2024. The question says the time taken to buy fuel at a filling station varies directly as the number of vehicles V in a queue and varies inversely as the number of pumps P available at the station. Full stop. In a station with 5 pumps, it took 10 minutes to fuel 20 vehicles. Find the A. Relationship between TP and V. B. Time it takes to fuel 50 vehicles at a station with 2 pumps. And C. Number of pumps required to fuel 40 vehicles in 20 minutes. Now, when you see this question, the first thing that comes to your mind is that this question is a question under variation. Yes. So, if you have been following our videos, you would have watched video under variation. So, let's use the knowledge of variation to answer this question. So, we have seen that we are to find the relationship between TP and V in the first place. So, let's get into the solution. So, solution. Let us interpret the statement. The time T taken to buy a fuel at filling station varies directly as the number of vehicle V. So, T varies directly as V. Small letter T varies directly as V. In a queue and varies inversely as the number of pumps P. Varies inversely as the number of pump P in capital letters. So this is the interpretation of that statement, such that T is equal to K. Once you remove the sign of proportionality, you bring your constant K multiplied by V all over, or let's say multiplied by 1 over P, and that is give us T equals to KV all over P. So this is the relation that is connecting it. So you can best put the relation in the value of K, the constant K. So this can be transformed to be T, small letter T, multiplied by capital letter P equals to KV. Then when we divide both sides by V, then we have V cancel V, K is equal to small letter T, capital letter P all over V. So now that you've gotten K equals to T, P all over V, let's find the value of K. Remember that T, as given in the question, says available at the station. Now, in a station with 5 pumps, it took 10 minutes. So T, 10 minutes to fuel 20 vehicles. So 10 minutes to fuel 20 vehicles. So time, 10 minutes. 10 minutes multiplied by, what is the P? 5. In a station with 5 pumps, 5 all over, what about the V? The V is 20 vehicles, so all over 20. So what we have is 10 times 5, 50 all over 20. 0 cancel 0, we have 5 over 2, and that's 2.5. Or 2 number, 1 all over 2. So let's say 2.5. So the value of K is 2.5, or we can say 2 number, 1 all over 2. So this is the value of K. So if this is the value of K, then the relation can be written to be that KV is equals to TP. Anyhow, then we can say that K, which is 2.5 V, is equals to TP. You can make any of this the subject of the formula. and that is the relation between the three variables. So now that we have gotten this, we can now proceed to B, to the question B. Remember, this is question A, then question B. Question B says, find the time it takes to fuel 50 vehicles at a station with 2 pumps. So let's assume that there's another station with 2 pumps and there are 50 vehicles there. So using that relation, what will happen? How long, or what's the time it will take to fuel the 50 vehicles? So we have gotten our formula, which is 2.5 V equals to TP. Then to find the value of T, in the case of question B, we are going to make T the subject of the formula. So now that we know that 2.5 V is equals to TP. So what we are going to do is, remember this P is capital letter. TP. So divide both sides by P cancel P. So T becomes the subject of the formula. T is equal to 2.5 V all over P. So we have to find this case when we have 50 V and 2P. So T, the time it will take, is equal to 2.5 multiplied by 50 V all over 2 pumps. So 2.5 multiplied by 50, what do we have? So this is just 5 multiplied by 25. 5 multiplied, because this is 5 times 10. When that 10 multiplied 2.5, you have 25. So that makes it 25 multiplied by 5. And 25 multiplied by 5 is 125 all over 2. So divide 125 by 2, you are going to have 2 here 1, 2 in 12, 6, 2 in 5, 2, remainder 1. So 2 in 1, so put decimal point, we add 0. 2 in 10 is 5, that is 62.5. So the time it will take is 62 minutes. This 0.5 means half. Half of a minute is what? Plus 30 seconds. 30 seconds. So this is the time it will take to fuel 50 vehicles in a station of 2 pumps within the given parameter. So 62 minutes, 30 seconds. So let's go to the third one, C. Question C says, the number of pumps that will be required to fuel 40 vehicles in 20 minutes. So what happens in a station where there are 40 vehicles and you have to fuel them in 20 minutes? So how many pumps should be at work? How many pumps should be at? So at this time or instance, we are going to make pump P the subject of the formula. So remember, the formula is that T equals to 2.5 V all over P. So we are going to introduce that T is equals to 2.5 V all over P. So to make P the subject of the formula, we cross multiply. So when we cross multiply, we now have PT is equal to 2.5 V. So to make P the subject of the formula, we divide both sides by T. T cancel T. Now P is equals to 2.5 multiplied by, remember the number of vehicle here is 40. So this is 40 all over, what's the time it will take? 20 minutes. So this will be 20. So 0 cancels 0, 2 here 1 and 2 here 2. So we now have P equals to 2.5 multiplied by 2. 2.5 multiplied by 2. 2 times 5 is 10. We have 0. Remainder 1. 2 times 2 is 4 plus 1. And that is 5.0. So the number of pumps that are required to fuel 40 vehicles um, 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 in 20 minutes is equal to 5. So 5 pumps. P is equals to 5 pumps. So you can see how simple WAEC past questions was and how WAEC questions could be set. Very simple. I believe you understood everything we did in this video. Bye bye. See you in the next video.